Hello, my name is Mark Black. In this video, we're going to explore how we could potentially use IBM Spectrum LSF as a scheduler for IBM Cloud Private. So we're doing this essentially to investigate how we could potentially put IBM Cloud Private 2.1 together with IBM Spectrum LSF Suite 10.2. So we're looking at what would that environment look like. We're looking at what would the possible integration look like, and I have an actual environment that I've set up with that combination, and I'm going to give you a demo. And finally, we'll make some conclusions, and we'll look for your feedback. So this really is a proof of concept. It's not actually a product at this point in time. This demonstration is really to discuss what's possible and to solicit feedback. Okay, so this is the environment that we're actually going to use. So I have a collection of physical machines installed with Red Hat Linux. On those, I've installed IBM Spectrum LSF Suite. So this is my LSF cluster. And I also have Docker and Singularity installed on several of these machines. So with this cluster, I'm able to run my regular sequential jobs with LSF. I'm also able to run my parallel jobs as well. I can run containerized workloads from LSF, either Docker containers or Singularity containers. I also have some of the machines installed with IBM Cloud Private 2.1. And from that, I can use my IBM Cloud Private GUI to submit my container workloads. I can also use the CLI. In the demonstration, I'm actually going to use the CLI to submit the containers. So in this environment, we have essentially a shared LSF cluster, and in it, I can use all of these machines to run my ad hoc jobs, my parallel jobs, my container jobs, and I've actually divided off to a small portion where I can run ICP as well, or IBM Cloud Private container workloads. These machines can also be used to run of course, the other types of jobs as well. Okay, so how do we integrate these two together? It turns out that there is a hook within the chart definitions or the pod definitions that allows us to specify which scheduler we're going to use. In this case, we're going to leverage that to interface with LSF. So in the definition, I basically specify the scheduler name, and I set that to LSF. So there are a few things that we need to consider for this. So when we are placing the pod onto the physical resources, there are things that we need to consider, such as affinity, and that could be pod affinity or anti-affinity, and there's also node affinity and anti-affinity. There's also a notion of a node selector. So the node selector is kind of analogous to the LSF concept of the resource selection string. So here we're selecting resource, we have a resource selector and we've set it to GPU. The other thing that we need to consider is how much resources we want to consume for these containers that we're going to start up. So in our container definition, we have this notion of CPU, and here there's a little bit of difference here. So here we're specifying either the number of cores or the number of millicores, right? So here I have 100 millicores, so this would be 1/10 of one core that I want to assign to this particular container. And memory, well, here I'm using 100 megabytes. So these are things that we have to consider in the integration. So LSF needs to provide functional equivalence for these things for a real integration or a seamless integration. So let's look at how we put these things together. So we have IBM Cloud Private, which is of course based on Kubernetes, and we have LSF installed across all of the machines, and I have this small daemon running that's able to interface the two environments together. As an administrator for IBM Cloud Private, what I've done is I've created some charts where I've specified as a scheduler name LSF. Right? And then those charts are available for the end users to take and deploy. So as an end user, I would come into my IBM Cloud Private GUI and pick a chart and deploy it. Or of course I could use the CLI. So I deploy the chart, and what happens is IBM Cloud Private will put that into a pending state. So it's waiting for the resource selection. It's waiting for, in this case, LSF to tell it which machines it should launch those containers on. So the daemon that I've created will listen for jobs in a pending state where the scheduler name is set to LSF. When it finds one of those, it will submit a reservation job to LSF to reserve the resources, and secondly, to get LSF to tell it where those resources are allocated. So once those, LSF allocates those resources, we now know where to place the container. So we pass that information back to IBM Cloud Private or Kubernetes, and it completes the deployment process. So I'm going to switch over now to my live environment, and I'm going to show you this this actually running. Okay, so this is my lab environment, and I have IBM Cloud Private already installed, and I've also went and configured my client so that I can get all of these parameters so that I can run the CLI. I'm not going to use the GUI to launch the charts simply because, well, I'm going through a firewall and running VNC, so it's a little bit sluggish. So I'm going to use the CLI instead. So let me get that out of the way. So let me just show you very quickly what I have here first. So this is part of a cluster of machines already. Oops. So you can see I have a number of machines. I have 2 boxes dedicated to be the master and master failover. I have a few machines that I've designated as the IBM Cloud Private Resources. And I have some machines that have Docker installed so I can run containers on these machines. And I have other boxes that I've installed that don't have any container support. I also have Singularity installed on these Docker hosts as well, so that I can actually have Singularity installed across all of the boxes, so I can run my containers on our Singularity containers on all of those machines. Okay, so that's the LSF environment, and I'll just show you that there are currently no jobs running. So I'm going to use the LSF jobs as a means to get the execution hosts, or so the host where I'm going to run the containers on from LSF, and provide that back to IBM Cloud Private. Okay, so let me get that process going. So I'm going to switch over to this screen here, and I have my integration daemon that I have created. So I'm going to just start that up. Okay, so it's just going to run in the background, and it's going to integrate IBM Cloud Private with my LSF environment. So here, okay, so I'm going to deploy this chart here. It has 2 containers, and each container has 2 pods. So let's deploy that. Helm install. Name my pod 2. Okay, it's deployed. We'll quickly get in here and see if we can see it. Got pod. Okay, so we can see that the state is pending, and we have 2 sets of containers and 2 sets of pods and 2 containers per pod. If we just flip over here, we can see, okay, the daemon has picked that up, and it is mapping that to LSF jobs. So it started up 2 jobs to reserve those resources. We can see that here if I run B jobs. And there we go. So these were the containers that are starting up, and you'll notice it corresponds to the job name, at least you can see the ending portion. And what's also happened is LSF has assigned the execution hosts. So this is where it wants to place those particular pods. So if we go back and run our kube control get pod, we should see that the state is now not pending anymore, and they should be running. And sure enough, it's running those. Let's dig in a little bit deeper. Get pod. Okay, so wrong command. Kube control. Scribe pod. Okay, and you can see it's actually started, container, and it's actually started 2 containers. Okay, so what would happen now if we go and kill this chart, right, or delete this chart? Let's do that and see what happens. Oops. List first. Okay, so we're going and deleting the pod. Our pods. Okay, so the pods are deleted, and let's see, the daemon is cleaning up, so it's killing those LSF jobs that it had used to reserve the resources. Okay, so the reservation jobs are gone, and the environment is basically reset back to its clean state. So let me quickly review what we have in that lab environment that you saw. So I have an LSF cluster. It's a small cluster. It's comprised of some machines that are the LSF master. I have some compute nodes installed on there that don't have any container technology. I have a few machines that also have Docker and Singularity, so I can run those container workloads from LSF. And the reason I have like a Singularity is Singularity solves a lot of the issues that you have, say, running Docker containers, especially for HPC environments. So it resolves a lot of the security problems that you have. It also resolves a lot of the connectivity to the data center systems that you typically want for your job. So it provides access to the user's home directories and essentially the same level of access that the user would have on that hosting OS. So for example, you will see if as a user you're able to see, say, GPUs. Well, when you run that Singularity container, you're also able to see those GPUs, and you don't have to do any additional work to make that happen. The other thing is you can simply B-sub a container. So it's kind of well, really it's quite easy to put your workload into a container with Singularity. And on a portion of those machines, I also have LSF, of course, all of the machines, but on a few of them I've installed IBM Cloud Private, and I have my master node, and I've also dedicated a few nodes to be worker nodes. And we saw that when we launched our chart, we saw that these machines were being used to run the containers. Okay, so in this environment, we saw that we were able to support both batch workloads and container workloads. We're able to run the traditional HPC workloads or parallel jobs, for example. We're also able to run new container workloads, and we can run those in like a dev test environment via IBM Cloud Private or more of a production type environment from, say, LSF. We saw that we were able to get higher security levels than we have traditionally with Docker using other technologies for running those containers. We're also able to see that we can bring mature scheduling and resource management to ICP via the LSF integration, and this gives us better control of our GPU and MPI resources. We also have massive scale as well. But I think the big thing that we get from this configuration is that we don't have any silos, right? So we haven't created a silo specifically running batch workloads and another silo specifically for running our IBM Cloud Private workloads. We have one shared environment where we're able to use all of those physical resources to run whatever workload that we want to run. So in this configuration, I think you can see that we get better utilization, which translates into better return on investment, which of course translates into better time for innovation. So as I said at the beginning of the video, isn't really a product at this point in time. This is really intended to solicit feedback from you, our users, and to really gather and understand what it is that you would like to achieve. So, if you find this video interesting and would like to provide some comments, we would certainly welcome those. And my email address is in the first slide of this deck. So thank you for watching. I hope you enjoyed that.